Good morning, ladies and gentlemen, and welcome to EuCNC 2018. Especially welcome to Slovenia, which is currently the fastest growing digital society. And it also happens to be the only country in the world with the word love in its name, which altogether I think makes it for a perfect backdrop for this year's conference. My name is Mojca Volk, and I'm from the University of Ljubljana.
And I'm Mihael Mohorčič from Josef Stefan Institute.
So first of all, this event would not have been possible without our patrons, so special thank you goes to Huawei Technologies, who's the gold patron of this year's edition, followed by Ericsson and Nokia, who are the bronze patrons, as well as Rode Schwarz, Telekom Slovenia, and Iskratel, also supporting this event. There's more than 500 of us this year, and we are from more than 44 countries, which, ladies and gentlemen, I would say that this audience and each and every one of you, this is what the 5G world is, really.
Yeah. Of course, we're not here only to explore the charms of Ljubljana and the Slovenia, but of course, we are also here for the content of this conference, or primarily for the content of this conference. And actually, after the opening ceremony, which is actually now started, I'm glad to announce we're going to have 4 distinguished keynotes today and tomorrow, 3 very interesting and hopefully thought-provoking panels, 17 technical sessions with 84 papers, 2 poster sessions with 37 posters, then 13 additional special sessions with further 60 or so presentations, 32 exhibition booths. So as you were entering this hall, you've seen there's a huge exhibition area. It's not just exhibition per se, it's actually demonstrations. It's really best of European projects showing their pilots, their demonstrations, their sort of prototypes. So please go and see what they have to show. And of course, not to forget, already yesterday things started with 3 tutorials and 8 additional workshops where we had 80 further presentations. So the program is really rich, and I believe each of you can find something for yourself. So just a little bit more statistics. We received 269 submissions this year overall, and I really have to thank 16 very devoted track chairs and more than 300 TPC members actually doing the very good review of all these papers. So that really contributed a lot to the technical excellence of the program that we have in the coming days. Of course, I shouldn't forget also the committee chairs who evaluated the proposals for tutorials, for panels, for workshops, special sessions, and the exhibitions. So it's really a conference in full swing. It's really as it should be, and as each of you also expects when you come to such a conference. So since many of you contributed to the content of the conference in one or other way, I'm sure there's something interesting in the program for each of you, so I hope you're going to enjoy it.
So we have many distinguished guests today among us. Special welcome to Mr. Boris Koprivnikar, our Deputy Prime Minister and the Minister of Public Administration. Welcome, and thank you for joining this event. Also, I would specifically like to welcome this year's co-hosts of the event, which is Mr. Pearse from the European Commission and Mr. Bojan Križ from the Directorate for the Information Society of the Ministry of Public Administration in Slovenia. Before I give my word over to the first speaker for today's opening ceremony, I just wanted to say that we have a very busy week ahead of us, but I wish for all of you to also find time to relax, to enjoy, to meet friends, and to learn and to have an experience from Slovenia that will go back with you and possibly bring you back someday also. So to help you with this unofficial part, we have a welcome reception tonight out front in the garden, and we have also a gala dinner tomorrow night in the city center. And I hope that you will be able to experience some of the beauties and the delights of Slovenia also on those 2 events. So I will finish with that. I would like now to invite to the stage our minister, Mr. Boris Koprivnikar, to give the opening address. Thank you.
Thank you. Welcome, dear guests, distinguished delegates, and welcome to Slovenia, which decided a few years ago that it will become a green reference country in digital Europe. And what this initiative and slogan on which we are working last years means is that we are, as a green country, seeking technologies that are kind to environment and kind to people and useful to people. And when it comes to the reference country, that means that we are not trying to invent new things and new technologies, but we are very passionate about finding the ways how to compose existing technologies in a working systems which can be of some benefit for our residents, for our country, and for our economy. And this is the way how we worked last years. And as it was said, because we are the fastest growing digital economy in Europe, that means that probably we are working something right. And 5G is one of the key factors or elements of the digital transformation. And we are now in the middle of digital transformation, which is just another industrial revolution. Only that this one is very wide, it's touching all aspects of our work, of our life, and it's happening very fast. But on the other hand, it's only a tool. We are developing new tools to gain better productivity. And this is what's the aim of the whole technology, that we have higher productivity, that we can feed our growing needs. This is why we're also searching the ways how to combine all those technologies and ecosystems in something that can in society work and results in better life of our citizens. We of course have to deal with the different aspects of digital transformation. We can improve productivity, we can improve our comfort, our creativity, our way of works. Definitely we can improve significantly our communication. But also digital transformation brings some minuses because there can be problems with the security, with the private space, with the fake news, for example. And these are all good and bad that we have to fight with. And I like to use analogies, and I often use analogy with electricity. When it was invented, they said we will never use it because it can kill people. Today, you know that we all use it. But the minuses of the electricity, we learn how to manage them. From the young age, we teach kids how do they have to avoid the electricity. We have different measures to use it safely. And the same is with the digital technologies. We have to not only develop the technologies, but also the safety measures, the skills and the tools, how to use them. And digital transformation is basically bringing some really deep changes in our world. It's becoming a language that we speak. And if we all speak digital, that we can communicate with each other, your work is crucial because you have to find a way how we can communicate, how we can synchronize our solutions, services, frequencies, that we can speak the same language and understand each other. And if we will be successful at that, then we can really significantly contribute that our lives in the future will be much better. There is another thing that's very important for us when it comes to digital transformation. We say there is steps that we changed everything that became electronical, digital, and then we call it smart. And when we talk about smart, we say whatever is smart is connected. And if you want to be all interconnected, we have to develop systems and services that can fit to each other, systems that can communicate to each other, that then smart solutions can be connected and composed from different technologies, different frequencies, communication services, and so on. And this is of crucial importance that we can use that tool very smart and to be connected all over. We have a very simple development strategy. We call it productivity sandwich. Sandwich, that means that as a government we have to develop optical communications in the ground. We call it communication or optical cable 100 megabits in 2020 to every barn. We plan to have with 100 megabits covered 96% of households in Slovenia, and already now the figures are very high. And also, we developed wireless communications, and the latest, of course, 5G. That's top part of the sandwich. Coverage with the LTE currently is 97%. So we are developing the communication layer, but what you put in the sandwich is services, open, and connectivity, services and data, open data. We open everything. We even changed the legislation, and we said there is not a question which data to share. We shift it. We say there is a question which data not to share. And we don't share the data that interfere with the personal, business, or governmental interests. But all the other data have to be shared as a public good. And this started the big economy and big, let's say, science about big data, which you have to collect first, then you have to understand. Not only understand the unstructured data, but also they understand the principles. And if you understand the principles, you can predict. And this is our passion, to predict what will happen in the future, what will happen with the economy, what will happen with the social field, what will happen with the weather, traffic, agriculture. If you can predict a little bit in the future, you can react proactively. And then you don't invest in correcting mistakes or bad things when happen. Then you invest in development because you spend less for correcting mistakes because you can predict them. And if you use this principle in a cybersecurity, in the government finances, in medical terms, and every other things, you can be, as a society, much more productive because you invest your resources that you have in development, not in fixing mistakes. And this is the basic of big data, artificial intelligence, and on all the other technologies. And when it comes to the technologies and way how to develop everything, we are talking about 3 ecosystems. One is international ecosystem. We have to cooperate internationally because none of modern digital systems stop at the border. So we have to be part of the European Commission, part of the OECD, global world, that we can synchronize our system in the international ecosystem. The second, maybe for me the most important, is ecosystem of collaboration, of cooperation. We established the Digital Coalition and many other measures when we communicate regularly with the academia, with the businesses, with the civil society and government. And we discuss together in equal measure to say what will be our future development, what we all together want. And then we share the roles and say what government have to do, what civil society have to do, what academia have to research and develop, and what business have to implement. And this ecosystem of cooperation is keen to speed up digital transformation. And the last very important system is ecosystem of technologies. We have cloud computing, we have artificial intelligence, 5G, broadband communication, blockchain, many other technologies. But none of those technologies can exist by itself. 5G is mean of communication for data, and if we have produced the data, we have to know what to do with the data. We have to store it, we have to do something with it, so we need HPC. So we need artificial intelligence to understand the data. If we use a blockchain, we produce another huge amount of data. We are building this fall, we will tender the IoT network nationwide. Again, it will produce additional data. It will be need for additional communication layers. And what I'm trying to say is that all those technologies are part of one big ecosystem. And if they are not synchronized, they cannot work. And we need 5G because we need fast, wireless, mobile communication, also for connected and autonomous drive and many other technologies that are coming. And to be successful as a society, and I'm not talking only about Slovenia, but it goes for any country, you need infrastructure on which you can develop services. If you develop additional services, you need better infrastructure. So this is a circle when infrastructure and services are supporting each other. But then, or all the time, you need skills. Skills to use new technologies and skills to develop new technologies. These are very different skills. Again, analogy, it's very differently if you drive a car or if you have to build a car. So you need a simple skill to drive a car, start, gear, steering wheel, or additional skill to build a car. That's very engineering skills. And you probably have to develop the other one, the development skills, but never forget also to keep it simple, user-friendly, and to develop the skills to use the services and technology. If we don't have users, we don't have market. And everything, what I'm explaining, have to be secure, have to be enveloped with the security, with the precaution, with the constant monitoring that we build trust in new technologies, and if we build trust, we will also use them. I'm glad that I can welcome you in Ljubljana, in Slovenia. I'm asking you to be part of that global ecosystem to speed up and always keep in mind that technologies and all other ecosystems are interconnected and that we can be only successful if we cooperate to each other and always keep in mind that we have to develop technologies that will improve the lives of our citizens. If we don't improve the quality of our life and work, then we miss the target. So be part of that ecosystem and enjoy in Ljubljana. Thank you.
Thank you, Minister, for this amazing speech that I think only reconfirms that there's very important topics that we're going to talk about this week. I would now like to invite our next speaker to the stage, which is Mr. Pearse, the Director of the Future Networks Directorate at the DG Connect of the European Commission. Please.
Thank you. Thank you and good morning, Deputy Prime Minister, ladies and gentlemen. It's a great pleasure to be back here in Ljubljana. I used to visit many times at a time when we were negotiating with what was then a candidate country on the telecoms chapter. And it's a real pleasure and surprise to see the development in this country. And I must say I was inspired by both the vision and the coherence of the Deputy Prime Minister's speech in Ljubljana's place and the way that you want to develop this country as a digital hub, as a fast-growing digital economy. It's also my pleasure on behalf of the European Commission to co-host this conference, and I'd like to thank our Slovenian hosts and for their hospitality, but also for organizing this event. I'm very conscious that this is only the tip of the iceberg, and the iceberg is very important. This is a very important conference for the number of technical discussions that will go ahead. And in previous years, keynote speeches from the Commission have tended to talk about our policy developments. Particularly, we've spoken about the digital agenda and what we're trying to achieve in the digital space. And of course, we have spoken on a number of occasions about the 5G action plan and exactly what we want to achieve at a technology, innovation, policy and regulatory level for the future of connectivity and communications in Europe. But I want to go back to basics today because I'm very conscious that a lot of the people here in this room and the other participants outside at the technical stands collect together here a hugely experienced and knowledgeable group of technologists and technology policy experts who will be crucial in what we want to achieve now for digital, for ICTs, in the growth and development of European economy and society, directly in line with what the Minister has just described as being the vision for Slovenia as part of Europe. And so what I'm going to do is I'm going to go back a bit and talk to you about our programming and strategy for the next big period, which we call our multi-annual financial framework, and then draw some conclusions from that. So this is called in Brussels bubble speak, and you'll excuse me if I use some of these terms as we go through the day, the multi-annual financial framework. But what is important is that that sets not just the financial framework for 7 years from 2021 onwards, but it actually also sets the strategic priorities. The Commission has just made its proposals, and they're on the table now of the Council and the Parliament. And it's very important that we have a discussion with important groups such as those represented at this conference in order to make sure that we get it right, but also that we have your support, and of course that we have the support of member states who have a similar vision about the importance of digital. Because digital is now a core area. The vocation of the part of the Commission that I work for, DG Connect, is to disappear when digital is mainstreamed into everything, every sector of the economy. So whereas 10 years ago we were talking to the telecoms operators and talking to the OEMs, now we are talking digital to every sector of the economy. Now we are talking about the rollout of 5G in the vertical sectors that don't consider themselves to be ICT sectors. The agri-food sector, the transport, the health sectors, and so on and so on. These are crucial for the development. Digital must be mainstreamed in the economic and social development perspectives from all of those sectors. We're now starting the negotiations, and you as industry, you as academics, you as researchers, and you as governments will have an important role to play in that. I'm going to throw this slide at you. Don't worry about all the detail. But this in one slide seeks to just represent the entirety of the areas of activity, the priority areas of activity, against which we're now trying to map a budget for those priorities. And we're talking here about billions of euros. It is, of course, a proposal. Member states may have different priorities. Some will be worried that areas that they consider to be important are not favoured, and others will want new innovations. And of course, there is always that tension about who pays in and who receives. But this is aimed at developing the whole of the European economy and society. One of the factors that I just put up on the last slide was, of course, that the budget is actually being squeezed. The Brexit phenomenon means that the available funds is decreasing from the number of member states, so we have to find new resources. But much more importantly, as the European Commission, we have an obligation to ensure that those resources are more carefully used and targeted to our real needs. If you look at the top left-hand circle, this is the area that interests us most today here at EuCNC with regard to the single market, innovation and digital. And what I want to do briefly now is to drill down into some of the specific proposals that we've made that will affect the work that is done in research, innovation, implementation, and regulatory policy in the area of 5G, connectivity beyond 5G, and all of the communications technologies and the internet ecosystem for the next few years. So the first thing to talk about is, before we get on to what is the main interest, which is, of course, the Framework Research Programme, the Horizon Europe Programme, as we'll call it, I'm just going to talk briefly about the two new innovative digital deployment programs that the Commission has proposed. The most significant innovation from our perspective in the entire package of proposals is, for the first time, we have a dedicated large-scale digital program called the Digital Europe Programme. And this seeks to overcome the current investment gap in digital, to allow Europe not just to catch up, but to overtake some of our competitors, and to really mainstream the concept of digital transformation in all sectors of the economy, as I've said. So this program is not so much about research or innovation even, but is actually about capacity building, about innovation, about deployment. Within that, we have to look at specific areas, and there are 5 focus areas, which will be important with regard to these digital innovations and this digital capacity. Those 5 areas, as you'll see, supercomputing or HPC, cybersecurity and trust, artificial intelligence, advanced digital skills, again another issue which the Minister mentioned as being essential for the digital vision to be realised. And lastly, of course, the actual deployment, the use of digital capacity, the interoperability of that digital capacity to make sure that what we are doing is coherent, cross-border, seamless, and basically that the systems do not lead to redundant or double investment. Those will be important because they will then knock on into the regulatory environment that is then created, including, of course, through the standardization ecosystem. The other implementation program, if you will, or deployment program, is called Connecting Europe Facility. Now that as such is an instrument that already exists, but here the Commission has proposed that there be a specific pillar with regard to digital, and that is really to finance digital connectivity infrastructure. So we are, of course, talking about continuing and expanding our high-capacity broadband investment, but also looking at specific projects that will seek to implement and accelerate what was identified in our Gigabit Society package of proposals, which also included, of course, the 5G action program 2 years ago. And so it does actually specifically include steps with regard to the deployment of 5G networks along transport paths. The Connecting Europe facility, compared to the digital program, one of the differences, and there is a significant difference, otherwise we wouldn't be duplicating efforts, is that this very much concentrates on cross-border infrastructures. A very large part of the CEF, which you don't see, is in relation to transport and transport infrastructures, cross-border and multi-member state infrastructures. But even there in transport, there is a huge need, as we all recognize, for digital. So this will also fund wireless connectivity to local communities. And as you've seen recently, the Commission has also proposed a Wi-Fi for EU scheme for municipalities. And then I go on to what is the next framework program, which is for us called Horizon Europe. These, again, I say, are Commission proposals, nearly 100 billion of investment of grant funding over a 7-year period, which is divided into 3 pillars. Now, many of you are familiar with how this works, but I think it's worthwhile just looking at the way that this fits into the Commission's vision. So whereas the LIGHT program that many of you may have worked with fits into the global challenge, there are changes. This is not just steady as she goes. Of course, we don't want to throw away the good practices from before, but there are also significant innovations. Just if I broaden the picture a moment, don't worry again about retaining everything that's here, but it's important to know the structure. We have 3 pillars, and underlying that we have, of course, the research support. And particularly, apart from the open science and the research infrastructures, and on open innovation, which is now going to make a much stronger effort with regard to SMEs and startups, who are an essential part of the digital ecosystem, again, in all sectors of the economy. We will have, in the middle pillar, in Pillar 2, key activities with regard to these clusters of activity that you see. And I'm going to be drilling down a bit further now. But what is important is that that pillar is broken down into 5 areas. And they do have a focus on the global challenges, the societal challenges, and efforts to reinforce digital technology, to reinforce technological and industrial capacities across Europe. So, whereas this will include and continue to include basic research across the 3 pillars, we will be looking more and more at digital transformation and how we can actually ensure innovation through the research efforts. If we look even deeper into the 5 areas, I will be arriving at the next generation internet, but before we do that, if you see that there are a number of areas under the digital and industrial transformation area, which are in themselves intervention areas. And here we must bear in mind that you should not allow yourselves, and we will not want any industry, any company, any research group to become pigeonholed. We must more and more be thinking across silos, across these 5 areas, even across the pillars, to ensure that we are actually using the best available science, that we're not duplicating effort. But of course, so that technologies and innovations can be used and reused, especially when we go to more software-defined anything, that the software modules can be reused in completely different activities, environments, and technologies. But if we just look very briefly there, I draw your attention to key digital technologies, to artificial intelligence and robotics, to high-performance computing and big data. These are all essential areas which are an integral part not just of the 5G and beyond vision, but of the development of digital across all sectors of the economy. For example, in terms of high-performance computing and big data, we're already launching a key initiative in order to ensure that Europe has the capacity to actually have the very high-performance computing and computing power to ensure that what comes through Internet of Things, artificial intelligence, is actually processed and processable in Europe. We then have to move that capacity out to the edge to ensure that when we introduce and roll out 5G, when we have the proliferation of IoT devices, that we do have the edge computing capacity to actually deal with it, that we have the underlying infrastructures for blockchain to provide the security at the edge for all users, for all processes. So this is why the innovation capacity programs that I've described to you briefly and the research and innovation, they must be working together. In many cases, we will be working in partnerships. In many cases, we will be pooling funding so that we go from the research through innovation all the way out to capacity building, which means for the community represented here at EuCNC, there are greater opportunities, but there are also greater responsibilities. You have a key role to play across the digital value chain. And then, if we come specifically to another of those specific intervention areas, the next generation internet. First of all, let me just look at the drivers before I actually get down to what that seeks to do. It is a vision with regard to those things which one could consider to be either worrying or perhaps in some perspectives negative about the huge growth of connectivity and the internet. We have to face up to those concerns without ever accepting that there is something wrong with the concept. What we simply have to do is, what is it that we can do to help to overcome problems, particularly of security and trust, in order to ensure that there is massive take-up of these technologies, because what we know are the benefits that will flow from that. But also there is the socioeconomic transformation. That is a fact of life. It has happened in every industrial revolution. What we need to do, whether it's with digital skills or with technologies themselves, is how can we actually use them to overcome the digital transformation, to overcome the social disruption, and actually float all boats, help everybody across all elements of society and across all of Europe, which is very important, to avoid the digital divide, whether that's economic or geographic. And it has huge opportunities. That is the ambition which the European Commission and the heads of government have already stated, and we must now implement that vision in order to ensure that we do actually have an internet that respects European values. What does that mean? Well, we have objectives in order to actually give voice to that. We have to, of course, avoid fragmentation. Europe has to operate as one digital economy. The minister referred earlier on to the importance of data. I regret that I have to leave this conference very early, because this evening in Brussels, in the Parliament, we have a negotiation with the Council on the free flow of data. Our proposal, which is part of the digital agenda, which is crucial to ensuring that we have the lifeblood of the digital economy actually free to flow, so that the digital heart of Europe can beat. And that is why an economy such as Slovenia, that seeks to put itself at the center, that frees up its data in exactly the way that the minister has described, that we reproduce that model of open data across the European Union with no barriers, with no localization restrictions, then we will have massive value added. We will also have massive savings in terms of productivity for even small companies who want to do business across borders, but they want to be based here, but they want to be competing with large competitors in Germany or Austria or Hungary. And that is possible through what we are putting in place. But we must also have the technologies. We must also ensure that not just the SMEs, but citizens trust the economy. And what that means is using the technology. We won't fight it, but we will stop the technology from controlling the individual, use the technology so that the individual can control their internet environment. That is the vision. But then that has to translate into technology. That's what you want to hear about. I'm coming to the end of my presentation. I want to leave you with these thoughts, which is that we have a lot of elements here. My slides will be available afterwards. I know that I've thrown some very busy ones at you, so you will get to see all of this. But this is key. This is already, by the way, in a written form in the intervention area on next generation internet. If you go to Annex whatever of the proposed regulation that came out 2 weeks ago, but now you have my slide. We have 3 areas within this intervention area. The infrastructure is, of course, vital, but it can't be a passive or a vertically integrated infrastructure as we saw in the past. It has to be vertical. It has to work with the enablers, the drivers, and it has to be completely linked and defined by the software and applications, which is why that this if I could do animation, and I'm very bad at PowerPoint, would be a very busy slide and everything would be whirling around. I want you to use your imaginations. I know you're all good at that. But what is essential is that we harness the technologies, that we actually develop them further here in Europe in order to ensure that the immersive technologies, that the personal data protection technologies, that the virtualization technologies, that the analytics, and of course the AI and algorithms are actually being developed coherently, that the technology is being used in order to allow us to have something which, one, empowers SMEs and business, but just as importantly, empowers European citizens. So it's going to sound strange to some people who are involved in a highly technical conference, which is vitally important to the Commission, by the way. But I want you to bring you back to the human-centric internet. So when I throw you my last and equally busy slide about what we've been talking about, I want you to remember that all of this means that we need a human-centric internet. We need an internet and an internet ecosystem that supports and attracts small companies and individuals and citizens in order to ensure that we actually embrace the sort of vision that the Deputy Prime Minister espoused for Slovenia earlier on. And that is why these mechanisms in good old Brussels bureaucratic speech actually become a dynamic and meaningful tool in delivering that vision. So there will be a lot of work done. Some of the projects that you see out in the exhibition area, which are funded through European research funding, in support of activities at national and even at regional level, are essential under Horizon Europe, under the infrastructure and deployment and rollout programs, the digital program and CEF. And I hope that you, in the future, will benefit. But in order to do that, and this is my closing word, as a community, as governments, as stakeholders, now that those proposals are on the table, everybody will be fighting over the money. People will be fighting over priorities. As the community that is driving our work in 5G, in connectivity beyond 5G, and in all the associated ecosystems, the technology for applications, for virtualization, etc., we need your support. You actually need to tell your governments, you need to tell your MEPs what you feel should be the priorities in order to deliver on Europe's digital ambition. Thank you very much for your attention.
Thank you, Mr. O'Donoghue, and thank you also for presenting what the European Commission has in mind for the next years, which will affect how the topics that we are talking about will evolve and develop in the next years. So now, last but not least, I would like to welcome on stage Mr. Bojan Križ. He's the Director General of the Information Society Directorate at the Ministry of Public Administration. Please.
Dear organizers of the event, sponsors, dear representatives of European Commission, dear Deputy Prime Minister of Slovenia, experts, ladies and gentlemen. I must admit, I am very proud and grateful for the opportunity that I can co-chair this event. Therefore, I officially welcome you to Ljubljana, the capital city of Slovenia, at European Conference on Networks and Communication 2018. The topic of the conference, 5G and beyond, is the topic on which Slovenia and the current government is working very hard the last few years, and we have concrete results to showcase. As a co-chair, I must say some words on the venue of the location. We are in the Cankarjev Dom, the largest Slovenian cultural and congress center, named after modernist Ivan Cankar, one of the greatest Slovenian writers, the greatest master of words. On the other side, the building was designed by the architect Edo Ravnikar, a representative of the Slovenian modern architecture, who succeeded by creation of architectural design with modern guidelines at that time. We continue their vision today in the field of information and communication technologies, where we strive for cooperation. Today, we have gathered the so-called modernists that want to see the development and the opportunities of 5G technology and beyond. My question was how to present Slovenia in terms of digitalization point of view. I do believe European Commission did a great job with introducing so-called DESI index, which measures each member state how societies are digitalized based on 5 key criteria. These are connectivity, human capital, usage of internet, integration of digital technologies, and digital public services. It's not a competition between member states, as we must act as a common single digital market, but it is a mirror to each member state how good or bad they are in progressing of digitalization in the country. My country, Slovenia, is ranked according to this index for 2017 as the fastest growing country in digital Europe. In 2018, we are still growing, and in May, we advanced for 2 places. For the purpose of the conference, I'm exposing 2 key criteria, connectivity and digital public services. In the field of ultra-fast broadband coverage, which means 100 megabits per second plus, we have 17% higher score than the European Union average. And in LTE coverage, we have 6% higher above the EU average. This year, Slovenia was also declared as a trendsetter in the Open Data Index, as we are radically opening the data, as our Deputy Prime Minister said. We changed the philosophy. We ask ourselves only which data not to open due to personal, business, or security concerns, as by default, all data must be open. We are aware that the baseline for all the new advanced services based on 5G, artificial intelligence, blockchain, Internet of Things, open and reusable data is crucial puzzle. As we have highly available experts in Slovenia, just for example, we have 1 artificial intelligence per 7,000 citizens, which is a world record basically. 1 ICT expert per 80 citizens. We have to work on gaining basic digital skills, which is a general problem in the European Union. Looking at the connectivity, where the European Digital Agenda goal is 100% coverage of all households with 30 megabits per second by 2020, we in Slovenia are always a bit ambitious by setting higher goals. According to Slovenian Digital Agenda and in our strategy, which we set at 2016, we agreed that in 4-year time frame, we will achieve coverage of 96% of households with 100 megabits per second, while the rest will be covered with 30. That will be a great infrastructure to move smoother and faster to gigabit society till 2025. Where we are now in Slovenia? Today, we have in total around 870,000 Slovenian households, and 60% of them already have an access to ultra-high-speed broadband connectivity. In 2017, we signed an agreement with operators to cover additional 23% of the households with 100 megabits per second, as they have commercial interests to construct with private funding. In 2018, we will proceed with the final checking of commercial interests of the operators, and on locations where there will be no commercial interests, we will declare such households as white spots, on which we have legal rights to finance with European Union funding for regional and rural developments. At the moment, we already have 2% of white spots and expecting the same number of white spots at the end of these processes. We will invest this year 36 million euros for 2 tenders to cover all white spots in Slovenia to fulfill Slovenian digital agenda by 2020. Slovenia has an excellent connection with mobile technology. 2G and 3G networks, we have coverage with 99% of the population. 97% of population has coverage with LTE signal, which is basically a great platform for testing 5G deployments and different use cases based on 4G and 5G as well. In regard to achieving ambitious goal in terms of 5G, so-called Slovenia 5G Action Plan, we have established a platform of cooperation named Slovenian Digital Coalition, which consists of different stakeholders, like government, NGOs, private sector in terms of mobile operators, companies, national regulatory agency, research institutes, and especially local communities. We also established different working groups, including the one for 5G deployments and use cases. We are very proud to announce that we prepared strategy for frequencies, which will be hopefully approved by government this month. So to have legal baseline for 700 MHz commercial auction already this year, as one of the first member states in European Union, with obligation of national roaming use cases for public protection in case of different disaster scenarios. We will cover main cities of Slovenia and having pilot zones in neighbor countries like Austria and Hungary, testing cross-border scenarios. What is fascinating, and from innovation point of view very helpful, Slovenia has in Electronic Communication Act clearly written that frequency in range of 3.4 to 3.8 gigahertz can be assigned for 3 years free of charge for testing purposes to facilitate new 5G use cases, products, and solutions. Slovenia is basically acting as a high-end laboratory of prototyping new and advanced technologies. In terms of 5G connected autonomous driving, we will enable 6 gigahertz frequency spectrum for vehicle-to-infrastructure communication, and in 2019, auction on 26 gigahertz will be enabled for communication in the tunnels. As part of Slovenia 5G action plan, we have established 2 pilot projects in the field of public protection and disaster relief and connected autonomous driving. While in addition, we are preparing this year the tender worth 13.5 million euros as national-wide and network for Internet of Things, dedicated to local communities. Concerning public protection disaster relief project, which consists of Slovenian National Regulatory Agency, which will provide 5G test frequencies, Ministry of Public Administration, which is responsible for the digitalization in Slovenia, different research and development institutions, equipment manufacturers, mobile operators, and first-line responders like Army, Police Department, and Medical Rescue Service. Each stakeholder signed own memorandum of understanding with Hungary for cross-border pilot testing. Government with the government, national regulatory agency with the national regulatory agency, universities with the universities. In the field of connected autonomous driving, intelligent transport system, and e-mobility, we signed memorandum of understanding with Hungary and Austria as well. The next connected autonomous driving pilot project is so-called City in a City platform, which will enable ecosystem to develop solutions for level 3, 4, and 5 autonomous driving vehicles. We started national-wide IoT platform for local communities, which will focus on application and services to improve quality of lives, like water and waste management, free parking spaces, and so on. And this will facilitate startup innovation processes. Platform will be open, enable different technology like 5G, narrowband IoT, LoRaWAN, and other wireless technologies. As a cherry on a pie, based on open data collected by different sensors, we want in next step to incorporate a prediction with artificial intelligence solution. We are aware of the responsibilities brought by dynamic change of digital environment, which affect all aspects of our private and business lives. To manage the digital environment, we need useful and comprehensive system solutions, including 5G technology, which shall be user-centric oriented. Therefore, we must not treat technology separately, but rather connect them in one technology ecosystem to address complete use case. Here, we must not forget on cybersecurity, which must be designed by default. I wish all participants a lot of success in acquiring new knowledge and making new contacts. Only connected, we can build a better and digitized world that will offer opportunities for sustainable growth. I wish you a pleasant stay in Ljubljana, and thank you very much.
So this was the official opening of the conference. So I would like to thank again to our guest speakers, Mr. Boris Koprivnikar, Deputy Prime Minister, Mr. Pearse, the Director for the Future Networks Directorate of the DG Connect, and Mr. Bojan Križ, the Director General of the Information Society Directorate. And as they are moving to some other responsibilities now, I would really like to invite our first keynote speaker, that is Michele Zarri. He's the Technical Director of the GSM Association, where he works on advanced technologies and 5G. And he will give us a talk on business model-driven 5G deployments. So essentially now we're actually starting with the technical part of the conference. So please, Michele.
Thank you very much. Maybe. Thank you very much for the invitation. What I would like to do, although this is obviously a technical conference, is to give an insight from the GSMA point of view of where operator will head to in terms of business. And that hopefully will drive the development of technology towards making sure that you can fulfill these business requirements. I would like to start with explaining very briefly who we are. We are a trade association, so we produce best practices, we all work collaboratively, and we try to do the greater good of the industry. We have several programs and projects, and we gather all the mobile operators in the world, plus 300 or more companies that are part of the wider ecosystem, that include the vendors, devices, software development, and so on. So in terms of what we are trying to do is really not working for operators, but working for the industry. When we started to look at 5G around 2015, we decided that the technology should have been developed elsewhere, because we are not technical experts to the level of universities, of 3GPP and other organizations. But our strength would have been to get the industry together on this track and ensure that we can get the ecosystem ready. And we leveraged our contacts with all the 800 operators, CEOs, and we conducted a survey. And out of this survey, we distilled a number of insights. And at the end of the presentation, you will find some links where you can download the report. I will not go through all of them. Just wanted to set the scene for how we created our goals. And we came up with 5 goals. What we want to do in the 5G era, this is the term we use to refer to the 5G network, but also the 4G network, Wi-Fi, satellite, and all the other components that create the connectivity framework for this for the globe. And we want to achieve boundless connectivity for all, meaning we want the predictability of a light switch. When you want broadband, you should be able to get it wherever you are and however you want to access it. We want to foster innovation and promote network economics, because that creates the right conditions for the next step, which will be there maybe in another 10-year cycle. We want to leverage this transformation and enable the vertical industries to participate to this revolution that the mobile has generated for the society with 4G, but maybe with 3G already. And revolutionize the broadband experience. Although this is becoming more and more a commodity, we believe there is more to do to ensure that all the society can get a decent mobile broadband, and we know how much it transforms lives. And finally, we want to create new use cases, because every new generation will require a new, fresh set of investments. And so we need to move beyond what we have done. We started with 2G, voice and text, started with embryonic internet access with 3G, developed, completed the 4G with 4G, proper and full mobile broadband solution, and started the IoT adventure. But there is more that we need to do to ensure that we can feed the pipeline and have sufficient investment that can be made in the system. And in order to achieve these goals, we devised a kind of four threads of action. I will talk a bit about standardization and new business models later on during this presentation, but I would like just to focus on this minute on advocacy and messaging. As you have probably seen, if you're involved with 5G, there has been quite a bit of hype. And it's very justified because we have seen how the GDP of a country can really correlate very tightly with the development of mobile services. We have seen how, as I said before, access to digital services changes lives for the better. And we have seen how the societal benefits can be reaped if you have the right conditions. So the expectation is high. And often you may argue that it's even too high, to the point where it could lead to some disappointment, and that is something that we are really worried about, because we started to see in the investors community some nervousness about the lack of a business case, or what are you going to do with even more broadband? Aren't people already happy with what they have? And if you don't have the investors community on board, then the advantages and the benefits that I described before cannot be realized. So in GSMA, we have tried to balance these two messages, because it's true, the business case has to be built, and hopefully I will explain later where we are in this journey. But it's also true that you shouldn't set the bar too high, because it will take time. Looking back at when 4G started and compare it to what 4G is today, there is a really, really large difference. So you can expect that 5G will start. Maybe it will not be spectacular as people expect, but it will grow over the next 10, 15 years. A normal generation lifespan reaches 30 years easily. So it was important for us to make sure that one of our roles was to moderate and educate somehow. And the second part that I will touch briefly in the rest of the slides, but I would like to provide a bit more information, is on the guiding the policymakers. So, of course, there are aspects that are very regional on policies, but we need to make sure that the policies are fit for purpose. You hear a lot about the densification of networks with 5G. You talk about millimeter wave with a very small range of cells. So the policies have to be adapted to make sure that you can develop a network in an economic fashion. The policies have to be adapted because there will be new partnerships coming along, and the competition landscape is going to change. There are some ideas that operators will move more and more into the service area as the competition moves away from the network area. So that's also something that needs to be reflected, and we need a dynamic adaptation of policymakers to the market while preserving all the good things that regulators can do by fostering competition and fostering innovation and so on and so forth. Again, another key area of our actions that I will not talk too much more in this presentation. So going to the core of this of my speech, I would like to discuss today how operators are planning to deploy 5G based on what they want to do with it, at least in the initial phase. But before doing that, I would like to go through 3 slides to just establish a common vocabulary, let's say. So I apologize in advance. I will use the term NSA inappropriately. I will use NSA non-standalone to refer to actually option 3, which is not the only non-standalone type of deployment. And I will refer as SA as this time properly, but I will most likely mean option 2, which is the standalone 5G deployment. So that is a kind of evolution in terms of radio, although the way it's been designed will allow some new creative types of deployment that were not possible with 2G, 3G, and 4G. The real revolution that we see, what we think when we look back 10 years from now to what 5G brought into the community, we think the revolution will come in the core network. The core network has adapted now to software engineering practices, it's cloudified, it's ready for the cloud, and it has a completely new paradigm that enables opening up interfaces, opening up the functions through APIs. So it really creates a new type of relation that can be established with third parties that didn't exist before, as well as all the flexibility that comes with it. So we really think that this will be the more fundamental revolutionary aspect of 5G moving forward. Maybe not next year, maybe not the year after, but surely the next decade will be the decade of the service-based architecture. And finally, since for the rest of the presentation we'll mostly talk about mobile deployments, I would like also to spend a few words on what is considered the first 5G use case, which is fixed wireless access. Now, some may argue that this is not really 5G, but in fact, it is, because you are using the capabilities of the new radio in frequencies that were not accessible with 4G. And even if, fair enough, fixed wireless access is a 30, 40, 50 years old concept, the way now it's being promoted will create both opportunities for consumer and enterprise, and will kickstart this journey towards 5G being the new way to access digital services. We are, of course, slightly afraid of the possible fragmentation due to different types of specifications, but we will work with the industry to ensure that scale is there and that adoption is as fast as they can be. So, as I said, we think this is 5G, and it has its role in testing the technology and so on. Now, as I said, what you have in mind is two deployments. So what you have seen continuing to survey the industry. We still have regular talks with our board members, which are the 26 biggest operators in the world, as well as the other members. And throughout the weeks and months, we keep track of what their intentions are, and we try to move them into standards concepts. So if they detect something that is missing, we ask what we can do to help. So the first one type of deployment, which is probably the most common that we have seen in terms of intention, is what we call the consumer-driven deployment, and is based on this non-standalone architecture, whereby you can use the 4G network as for the basic connectivity, and add ad hoc hotspots of high connectivity with 5G access. So that creates the potential to deploy 5G where it's needed, when it's needed, and having an organic growth of the 5G network over time without touching what the core network looks like, so that the device I have in my pocket now will use the same protocols to communicate with the core network. Other advantages of this is that the modifications on the LTE network are relatively minor, and so are the modifications on the packet core network of 4G. And where we see it more needed, it's in those countries where maybe the Wi-Fi infrastructure or fixed network infrastructure is not very well developed, and Middle East, India could be two examples of those, or where the users of the mobile broadband are really using it quite a lot. We're talking about 1 gigabit per day per customer, as it is the case in Finland today. But other countries are quickly coming up to high level of usage that make operator challenging proposition of offering this capacity. So very much NSA is a capacity layer that you can add quickly and will over time move to some other type of deployment, but it's a safe way to start. And it's also a new way, because if you look at the way 2G, 3G, 4G have been deployed, this was not possible because the dual connectivity wasn't there. And so really, it was the way to kickstart 5G is probably this one. Talking about consumer, the person-to-person services are quite important. So we have been also looking at how the voice continuity will work in the various scenarios. And another advantage of this LTE-NR connected to EPC in this option 3 scenarios that you can benefit from a lot of the technologies that were used in 4G to make sure that your call continues when moving from one type of coverage to the other, which is not the case yet for when you use a new type of core network. Although Alpine standards are working on a possible solution for that. And finally, another important aspect for consumers is roaming. Here we noticed that we will not be able to have all the seamless roaming between all the scenarios. So if some operators decide to follow a different path, they could end up with with the incompatible type of 5G roaming. It's not an issue that will exist for a long time. In fact, over the course of the year, it's probably going away as more and more operators migrate towards a 5G core, maintaining maybe a virtualized 4G core somewhere in their network. But obviously, it could be a problem in the initial stages where you cannot get 5G service when you move into your roaming partner. And why is it important? Because one thing I didn't mention is that we shouldn't look at this consumer-driven as a broadband, mobile broadband only. As it was the case when with 4G operators opened up a throughput for everybody, we saw new services coming up that people couldn't think about in the past. Uber came to exist, and Airbnb. So every new generation, every new additional capability gives the opportunity to create new services. And we believe that with the low latency that 5G will deliver, with the reliability that 5G will provide, we can hope that there will be services that we didn't consider yet because not feasible or just not practical to realize. And there will be those services may not be available in roaming if you end up in one of these two scenarios. But as I said, I hope that was the biggest problem because it's not really, it's something that we will handle and we have time for that. Moving on to the second type of business-driven deployment, this is what we call the enterprise-driven deployment. It's based on using the 5G core network. This new core network, which has APIs exposed and is a service-based, so it can be composed more easily to create different types of configurations. Who is looking at that? Mostly operators who want to address the business-to-business market rather than business-to-consumer. So operators who want to enter this verticals engagement. And also operators who have no pressure to deliver a high capacity, except maybe in some hotspots. So they're not so interested in having the extra 10 gigabit per second per square meter in their configuration. This is the classical type of deployment. Interworking with the previous generations is at core network level with standardized interfaces. And it's a self-contained system that really reaps all the benefits of 5G. So you don't have the limitations that could be imposed in the previous model where you have your bearer half on 4G and half on 5G. The impacts are big, and in fact, there are operators in the world who do not want to risk compromising their existing setup, and they will go for this option more likely. I would like to spend a bit more time now on why this enterprise-driven is really what changes from what you've seen the past 20 years, pretty much, where it was a very business-to-consumer oriented. It was data plans, 3 minutes and texts sold to consumers. And this 5G core will not only make network slicing reach its full potential, so a lot more than what you can do today with 4G. The 4G network slicing is not as flexible or not as efficient as it could be. Think about NB-IoT is a complete overlay of a network. It's not really a slice. Given an APN, customized APN to some set of customers is not really a slice. But besides this creation of bespoke networks that really fulfill the needs of individual users, it also creates a kind of revolution in the value chain. So in the past, you imagine the fixed network operators were service providers addressing the full value chain, service enablement, and up to providing devices. But now with network slicing, you create a new type of partnerships where operators can do as little as providing connectivity in the last mile, or as much as to provide a full end-to-end service which is managed by the operator. And everything in between is possible. And there will be companies who are very high know-how and technical skills that they will want to use their own systems and just integrate parts of the mobile network capabilities into their system. And others that instead will want a full solution working and paying some money at the end of the month. This is very important because all this market, maybe with the exception of some of the basic IoT, are all to be invented, and they provide this incremental opportunity that makes the justification of investment possible. Otherwise, justifying the investment in 5G based on the hope that customers will pay more for a better broadband are probably a dangerous premise. And just since this is very much a business issue, we are working to try to simplify the introduction of network slicing. We're trying to rationalize it, and while keeping it completely flexible, we're trying to say, let's start small. The reason we're doing that is because we have seen with VoLTE, with the voice over LTE, that too many options, too much freedom of choices between possibilities creates fragmentation, and that's never good. Besides, we need to make sure that we create a business model that fits the wider possible audience, so you don't create really niche business models. How did we do it? We started with taking some vertical industries, sectors, automotive, logistic, industry, automation, and so on, and extract the use cases. Because at the end, what the network provides is use cases, it's not a general solution. And we took these use cases and we tried to figure out what are the underlying requirements. What is it the network needs to do for the company who has this use case to be willing to use the mobile network. And we did desk research, but we did conducted interviews. We collaborated with the 5GAA and with the 5G ACIA and with all the other sectorial organizations that gather their communities and create those requirements. And we came up with maybe 60, 100, I lost count now, type of use cases that then we try to map into technical features. So we are, for us, a network slice can be fully described with a template that we call a generic slice template which contains a number of attributes in terms of performance features, operational features, functional features. When you assign values to those attributes, you create a description of a slice that can be implemented and that hopefully is recognized and understood by all the stakeholders, the vertical customer, the vendor, and the operator. An example of this process is for telemetry. So what we did was to ask car manufacturers what was their use case, converted into requirements, and the requirements became technical requirements that are human readable. And then out of this requirement, we populated our generic slice template to form a slice that fulfills the telemetry use case. Our hope is that at the end of this process, we'll find out that there are a few number of slices, maybe 10, maybe 15, that actually can cover 90% of the most popular use cases. So we can hope to create a kind of safety net, a kind of set of slices that all the operators in the world will deploy on top of their customized bespoke slices for their bigger customers. But they will have these 10 slices that you can always fall back to. What will it do? It will enable a simplified type of roaming. Will enable vendors to build equipment that is tested against those slices, devices that know that these slices exist, and will create the conditions for starting the business of network slicing and growing it. Finally, I would like to just quickly mention the fact that I spoke about these two models, but they're not mutually exclusive, obviously. They are the starting point based on your conditions, based on market readiness, based on the penetration of 4G and maybe the regulatory environment, availability of spectrum, and so on. Tens of parameters that determine whether an operator should go for one type of deployment or another. But moving forward, we imagine that all the operators will have multiple types of configuration in their networks. They will have islands of non-standalone with islands of standalone, and maybe they will at some point consider phasing out their 4G network or 4G core, or just leave a life support for roaming customers and benefit from the full advantages of having 5G. So we don't want to put a time on that migration, but we believe that, as I said, standards will continue to evolve. The 5G core standards have been finalized last week, but it probably take a while, especially if we are aiming for a multi-vendor type of environment to have products ready. But as it was the case for 4G, within 5 years, we think that there will be a more common type of configuration. I close with a slide with some references. So all that I said in the previous 30 minutes is somewhere hidden in those documents that are all available on our gsma.com website, and you're welcome to download them at your leisure. And those are my contact details, and I don't know if I have time for a question.
I have to join here. So thank you very much for this talk. We have a time for 1 or 2 quick questions from the audience. Yes? I'm not sure if this works.
You have to switch it on, maybe.
Thank you very much, Michele. My name is Monica Buscher from Lancaster University. The question is inspired also by the previous speakers, and it is, are we ready for 5G? And I'm thinking about digital ethics. So a lot of the work that you describe is about building the pipelines. And we're putting a lot of effort into innovation around the pipelines. But even the European Data Protection Supervisor's Office recognizes that the GDPR actually is at odds with a lot of the potential of the technology. So if you think about purpose binding and data minimization and deletion, and why is that? At the moment, there is very little innovation into the human practices of wanting to share data, feeling and being able to practice control over information flows. So if you could tell me what you think the biggest challenges in terms of innovation in digital ethics are and what solutions you know of, that would be great.
I feel that the market is ready, although they don't know it maybe. The challenge I see is for operators to change their mindset. Operators in the past 20 years, what they've done really, really well is to create this business-to-consumer market. They know it, they know how it works, and they've provided an excellent service. And now they have to go back to their roots of becoming service companies, selling services and creating services that are actually bespoke. They are not off the shelf. Every customer will have its own requirements, and you can, to a point, have some baseline, but then it's really a transformation also the way the channels of operators will change the sales channels. And indeed, the other point you mentioned is how do we deal, especially in Europe, with net neutrality? Because network slicing potentially can create a big net neutrality headache because you provide the same service maybe with two different SLAs. All issues that GSMA is already engaged with operators, so hopefully with your help we can move them forward.
Any other burning question, or?
I'll be around in the coffee.
You will be around, so
yeah.
You're still around for an entire day today? More
Almost,
or less?
almost.
Okay, so then I will just try to save some time. So thank you, Michele. So then we'll just move to the second keynote speaker, that is Professor Thomas Kürner from Technische Universität Braunschweig in Germany, working on mobile radio systems, and he will, I believe, try to answer if terahertz communications are an option for wireless network beyond 5G. So, please.
Yeah.
Go ahead.
Thank you very much for inviting me to this conference. Ladies and gentlemen, welcome to my talk about terahertz communications. So this is just a structure, so before the conclusion, it's 4 blocks. First I will give a short motivation, why terahertz communication. Then I will present 2 research results that we have done in Braunschweig in the last couple of years on propagation modeling and also on setting up demonstrators. And then in the final block I will talk a little bit about standardization and regulation and what's going on in Horizon 2020 with terahertz communications. So if we go to ultra-high data rates, so let's say 100 gigabits and even beyond, there is basically 2 options, either using the spectrum that is currently available and identified. Of course, there is some work going on identifying more spectrum, for example, at 60 gigahertz. So there is 7 gigahertz available worldwide, plus some gigahertz more. But if you want to achieve 100 gigabit per second plus, you have to go to quite complex transmission scheme, probably look on massive MIMO. So this is one possible path. The other option would be just to go for more spectrum, to go to 20, 30, 50 gigahertz of spectrum for one connection. But then, of course, you are facing a problem. You have to get this spectrum. And if you look to the spectrum allocation, there might be some spectrum available beyond 275 gigahertz. So some people say it's unregulated spectrum, so this is not completely true. There are some constraints. I will come back to that at the end of my talk. But if you go to that frequency, of course, you need high gain antenna to compensate for the high path loss, and this is one part of the challenges we are dealing with. Of course, what is possible with this with this large bandwidth, you can go to relatively simple modulation schemes. So on the baseband, things are a bit easier. On the other hand, you have more complexity on the RF chain. And also you have to deal a little bit with some frequency windows with some atmospheric effect. So the challenges are, of course, you have to develop the proper channel models. RF front-ends, antenna concepts are important. You have to look also to the baseband transmission techniques, and also the whole area of standardization and regulation is also on the table for this frequency range. So now, having taught about 100 gigabits, so these are possible applications that you see here on this slide. Of course, for a wireless LAN type of application, you can imagine that you might have more higher data rates in a conference room like that if everybody is doing time-consuming data downloading during the conference. We have heard just in the talk before, fixed wireless access might be one option. Kiosk downloading. Backhaul, fronthaul might be something. Then there is some trends that you replace the fiber within data centers by wireless link in order to have a more flexible reconfiguration of the data center. And there is also a need for high data rates within devices. So, for example, within the video projector, within a camera, also a wireless link might be an option where this frequency range is of interest. Now let's first dig into the first part, which is on propagation characterization. So whenever you design a wireless communication system, and if this wireless communication system is either operated in a new frequency range that has not been used before, or is operated in a new environment where it was not used before, or and this is the case for some areas in terahertz communication, both things apply, then this triggers, of course, some work on channel characterization and channel modeling. And, of course, the first step are always to do some channel measurements in order to get some basic understanding what's going on there. And you see here some of these new environments and some of these effects. Now let's start with modeling the indoor propagation channel. That's also with the application where we started with terahertz communication. So the tool of choice is, of course, ray tracing, which was shown that it works already quite well at 60 gigahertz, and at 300 gigahertz we are closer to the visible light, so it works even better. So this is not the ray tracing itself, the geometric engine. This is not a research topic. But we have to deal with the interaction with the objects in the room by reflection, by scattering. And there, the wavelength brings some new challenges. So if you have a flat, smooth surface, no problem, you can use the usual methods. But how about surface roughness? And take into account you are at wavelengths at 1 millimeter and below. And you know, when a wave interacts with an object, the ratio between wavelength and object size matters. So you are coming into the direction where even small roughness plays a role. And even multiple layers may play a role. So if you have a wallpaper on top of a concrete wall, this may cause multiple reflections and some effects that you may see. I will show you some work that we have done already years ago on investigating rough surfaceness. So you see here on the slide typical rough surfaces that you can find in rooms, and we have done two kinds of measurements. First of all, we have measured the reflection capability with the terahertz time domain spectroscopy techniques, where you have a small laser pulse and then you get a response by doing a Fourier transform over a wide frequency range, and you get the reflection factor. So this was for the measuring. Then for the modeling, we looked to the literature, and there were models available to model these rough surfaces here that you see here. But you need for these models the standard deviation of the height of this surface. Now, how to get this surface? Now, we were quite lucky in Braunschweig. The German Institute of Meteorology is located in Braunschweig, and they have a nice equipment where you scan the surface with a laser and produce a digital height model of this wallpaper, for example. And from that, we can derive all the statistics that we require, and we put this parameter, the height standard deviation, into our model. And you can see here the result. This is quite interesting. So the red one is the model over a wide frequency range. The blue one is the measurement, so it fits quite well. And the most interesting thing, and I show this slide quite often to my students, is this green line. This is the reflection coefficient or reflection factor that you would have if you don't take into account the rough surface. And you see, this is very close to the measured and the modeled here at 100 gigahertz, and it's far away at 300 to 400 gigahertz, which means that this surface behaves as a smooth surface at 100 gigahertz and behaves as a rough surface at the higher frequencies. Now, we also did some measurements in whole rooms, and first we used a vector network analyzer, and in order to overcome the high path loss, we used a high gain antenna, horn antenna, combined with a polyethylene lens, and then use a mechanical rotational unit to scan the whole room. Vector analyzer is quite slow to scan a small room like that. This just takes 90 hours, so this is not a practical thing. So therefore, we'll show you in a few seconds another measurement equipment we have for that. But before, I would like to show you some results that we got here in this room. So this is the measured signal over the angle of departure at the transmit antenna and the angle of arrival at the receive antenna. So you see a lot of spots where we have high receive power, and these angles with the red circles, this is what we get from a ray launching algorithm. So you can see that we have catched the most significant rays here, what we also measured. Now, in order to be a bit faster, not to scan the whole frequency range, but to do the whole thing in one shot, you need a time domain measurement, and we're lucky that we were able to buy a channel sounder, also applicable to this frequency range, which works on a PN sequence, so it's now in time domain, and you can measure a large bandwidth, namely 8 gigahertz of bandwidth in one shot. And so we can put this also on our rotational unit. So here is the central unit that you can see here. You see two boxes here. The principle it works is that first a signal is generated in the frequency range 5 to 13 gigahertz, which seems to be a very odd frequency range. The purpose is that we have frequency extensions both for 300 gigahertz and 60 gigahertz, and we want to target the bands that are standardized here in those frequency bands, and in order to have multipliers, the only solution was to work with 5 to 13 gigahertz in the baseband unit, or ultra-wideband unit as we call it. So here is the data. So the bandwidth of the channel sounder is 8 gigahertz, and this enables us to measure 17,000 channel impulse responses per second with those frequencies. The baseband unit principle allows us to do an up to 4 times MIMO system. However, we have for 60 and 300 gigahertz only 2 links available each. It was just a matter of the money, but we have the possibility to do the measurements simultaneously at both frequencies. Now I would like to show you results from one measurement campaign we have done at these 3 frequencies. So here, this is the 9 gigahertz center frequency with the antenna. This is the setup for 60 gigahertz. This is the setup here for 300 gigahertz. And we have done this in a small seminar room at our institute. As you can see here, the setup. And this is actually the results, similar representation as before. So you see here the 3 frequency bands, and you see also the 2 polarization, horizontal and vertical polarization. Obviously, in vertical polarization, we have much more reflective rays. So apart if you, of course, the three figures at the three different frequencies look a little bit different due to the different dynamic ranges, but what you can see is that the main rays that we also see at the lower frequencies can be also seen here at 300 gigahertz. This is an important fact where I will come back later when I'm talking about device discovery. We have also simulated this scenario and again compared the results with our ray launching. So here you see the results for 300 gigahertz. Again, you can see that we have catched in our simulation the most important signals. So here, for example, those measured and those, and we see also this signal and this signal in here. So now let's come to a second environment, which is intra-device communication. So communication, wireless communication within a camera, within a video projector. And I was quite surprised that this is of interest. We have been approached a couple of years ago by the Canon Research Center in Rennes, in France, about this problem, and they have asked us about do some investigations on propagation at 300 gigahertz in such environments. So the first thing we thought, okay, that's easy. There is this electromagnetic simulation tools available, and they can be used to predict what's happening in such a device. But then we did some calculations. You have to discretize the whole thing with 1/10 of the wavelength, and here again the small wavelength catched us. If we would use a medium scenario like a video projector, 20 centimeter time 20 centimeter time 20 centimeters, we just would need RAM of 2.9 terabyte, and the whole thing would run for 188 days. So this was not an option, so we came back to ray tracing again, which means that we have to do some modeling and then to do some measurements. Now, measuring such a device with a vector network analyzer, for example, this is another big challenge. You cannot do this, or the only chance to do this was to build a mock-up. This was done by our mechanical workshop, a flexible box where we can exchange walls, where we also can inside exchange smooth sides with PCB boards, for example, and we drilled some holes into the walls which enable us to put the frequency extensions at defined positions and then do some measurements. Before I show you some measurements, I just would like to show you one slide. We also did some modeling how reflection and scattering behaves on a PCB board, because again, due to the wavelength, this is a highly scattering environment. And we set up a model that takes into account within a certain area of a specular reflection point, multiple reflection point, processes, and the model then depends on a couple of parameters that we could tune also from the measurements. If you're interested in more details, so there is a paper that we have presented in the UCAP 2017. So this is one of the results we have achieved. So we had the setup where we put in the antenna here on this side of the box, and those two walls are smooth, and those two walls which are green, they are covered with PCB boards. We did investigations on different sizes of the box, and I would like to concentrate on the larger side where this was 16 centimeter, this difference between the two PCB boards. And this is the black and the gray curves are measured impulse responses with two different settings of the antennas, and the colored impulses, these are the impulses that we have simulated using this PCB model, and we see that we have to take into account up to 3 scattering processes here in the box. So this is about a short overview of some activities on propagation modeling. But now the second challenge is to set up an RF system. And from 2013 to 2016, we were involved in a project that was funded by the German Ministry of Technology and Science. And it was a collaboration project between the University of Stuttgart, Fraunhofer Institute for Applied Semiconductor Physics, and TU Braunschweig. And what we actually did there, we set up a demonstrator for a 300 gigahertz communication system. and the distribution of work among the three institutes were that the RF design was basically done by University of Stuttgart, also the put together of the whole system. Then the Fraunhofer Institute produced the integrated chips, and we did the development of the antenna system. Just to show you the setup of a demonstrator, the first version was just one where we have shown some mechanical beam steering. As a source, we used an arbitrary waveform generator, and as a receiver, we used a digital oscilloscope, and then there was some communication between receiver and transmitter, and this enabled us a situation where transmitter and receiver actually could steer on each other. So here you see the whole system with transmitter and receiver, and the waveform generator and the digital oscilloscope attached to transmitter and receiver. And I have a short video where you see how the two antennas are steering to each other. First of all, on a mechanical way, using the rotational units that I have introduced to you beforehand. And now in a few seconds you will see that the line of sight link will be blocked, and as a consequence the antennas will look for alternative rays. Of course, we have set up here this demonstration in such a way that there was a nice reflector nearby. Now you see that the two units are looking to play via the reflection, and then after some time the whole thing went back. Of course, a mechanical steering is not something that you would like to have in a real system. Therefore, for the second demonstrator, we also applied an antenna design for electronic beam steering, at least for a proof of concept. One of the constraints was basically coming from budgetary reasons within that project, that we could use only 4 channels, because we have to build 4 RF channels at 300 gigahertz for this antenna, and so we used 4 antennas, and we used the concept of using horn antennas, so 4 small horn antennas. So this is the whole thing, but the antenna itself is this construction, so 1, 2, 4 elements. The remaining part is just to enable us to connect the 4 RF chains with standard waveguide connectors. This is the simulation of the antenna diagram of a single element, and this is the diagram of the whole array. So you can see that we have around 60 dB more gain here for the array. One problem, of course, that you are facing if you are doing phased array antennas at that frequency range, that you have to get the antenna as close as possible together in order to avoid side lobes. And actually here you see what the problem is. If we steer the antenna by a minus 20 degree, there is a second side lobe coming up here on this side. Now, we also measured, of course, the characteristic. Unfortunately, with a vector network analyzer, you don't have enough ports to measure the whole array, so we could measure only the single antennas. So here you see the single antenna. It's a good match between the measurement and the simulation. You see here also some asymmetries, which is from the outer 2 elements, which don't have a left or right-hand neighbor, of course. Then we put the whole thing together and did a demonstration of the electronic beam steering at the EuCNC conference of NGMN in October 2016. You see here the whole setup, and you can see here the signal, here all the cabling, which is of course quite an issue. It's a prototype, of course, and we were able to steer plus minus 20 degree in an electronic way. One of the problems, of course, of using high-gain antennas, and if you want to use this in a wireless LAN type of environment, is that the 2 devices have to find each other. And we had one idea that we use first a lower frequency to roughly discover where the device is, and then afterwards we do a steering with a high gain antenna at 300 gigahertz. A prerequisite for that is, of course, that the spatial characteristics of the signal are similar at the different frequencies, so I have shown you that measurements before, and then with some clever algorithm to distribute the scans at the lower frequency and at the higher frequency, you can speed up the whole process quite significantly. And I have used our channel sounder also to do a demonstration of this concept, a little bit simplified setup. So we have a 30 increment at the 10 gigahertz range and a 5-degree increment at 300 gigahertz, and we have done this in a large lecture room. Of course, therefore, we have to staple on top 3 of these elements. You see here how the whole surge works, first at the lower frequency and then at 300 gigahertz. And again, I have a video how the whole thing works. So now here you see the receiver. In that case, it's the receiver that moves. Now it moves here at the lower frequency. You can see here the impulse response for the 300 gigahertz and for the ultra-wideband signal at 10 gigahertz. And now the system goes into the fine step surge at 300 gigahertz. In this demonstration right now, we just use the received power level, but for future, we also can imagine to exploit the whole impulse response. Now, apart from the research, there is also a lot of going on in standardization and regulation. And already in 2014, within IEEE 802, the project 15.3D was triggered and started to build an amendment for a first gigahertz at 300 gigahertz. However, there the target was clear to go for application where the antenna is fixed, so that we don't have the whole hassle about the beam steering. And the target was to develop a standard from in the frequency range 252 to 325 gigahertz with these 4 applications. And actually the standard has been completed last year, September, and has been published in the meantime. Here you see the 4 applications. It's intra-device, kiosk downloading, backhaul, fronthaul, and data centers. They seem to be quite diverse, but all the 4 have in common that it's a fixed link. So it's just a matter basically of the output power and of the antennas that you are using, but the transmission principle is the same. Some key facts about this standard. We have used basically the MAC that was developed in a parallel project on 60 gigahertz, the 15.3E standard, and because they also had a point-to-point nature with highly directive antennas. We have defined 8 different channel bandwidths, which are multiples of 2.16 gigahertz, which is the original 15.3 bandwidth. Have defined 2 different PHY modes and 3 channel coding schemes. Again, it's the same coding schemes as developed here in this standard. So once chips are available for this standard, also these chips will be available for our standard, and this group that has developed the 15.3E standard are targeting to have a system up and running at the Tokyo Olympics. This is the channel plan that we have for the different channels and bandwidth that we have defined. So it goes from 252 to 321 gigahertz. We also did system evaluations and just would like to show you one for the backhaul fronthaul application, where we have assumed that we would use a transmitter output of 1 watt, what is possible with a traveling wave tube amplifier as it is developed, for example, by NEC in a research project. And if you apply 40 dBi antenna gains at both end of the link, what you can achieve, for example, with a dish antennas. And then we have assumed, of course, 20 dB atmospheric attenuation, which would correspond to the attenuation that you would have at a very heavy rainfall in Bangkok. We've taken that data from literature, and you can see that it is feasible to have a couple of hundred meters of coverage range with that. So the second activity apart from the standardization is, of course, the regulation. In the beginning I said, okay, the frequency is not completely unregulated. It is not assigned to any specific service right now beyond 275 gigahertz, but there are constraints because there is passive services like radio astronomy and Earth exploration satellite service that are operating with very sensitive antennas, and they have a certain protection which is ruled in this footnote 55665. Of course, this regulation still would allow us to operate terahertz communications, but the national administrations would have to agree individually, and therefore at the upcoming, this is the possible interference scenarios, which I will skip. So at the upcoming WRC, there is one agenda item, 1.15, where this sharing between the terahertz communication and especially the Earth exploration satellite services are studied. And the reason is by investigating this situations, we are targeting to either get a dedicated allocation or at least to get an a footnote, that clearly explains the conditions under which we can operate that system. So just last week, Working Party 1A have finished their basic studies on these sharing studies, and now the negotiation for the appropriate formulations have started. Now you may ask what's going on in Horizon 2020. There have been already some projects that have been finished, for example, the IPRO project, where some of the measurements that I have shown you have been done. But last year, 6 projects from the cluster call ICT09 on networks beyond 5G have started. So you see the 6 projects here, and more or less all of them are dealing with terahertz communications, and explicitly with terahertz communications. These 4 projects, the EPIC, the Terrapod, Terranova, and the UltraWave project. I'm personally involved in the Terrapod project, which is about wireless terahertz links in data centers, and my students are just on the way back from Ireland. They have measured with the channel sounder in 2 real data centers the last two weeks. There is one project that is not mentioned yet, but that will start within the next 2-3 weeks. There was another Beyond 5G call for European Japan projects, and we were happy to won one of them, so the Thor project, which will start soon, which is about setting up a demonstrator for backhaul fronthaul applications based on components available already at the partners. So this brings me to the conclusions. I have shown you the potential for frequency bands beyond 275 gigahertz, have shown you something about propagation and demonstrators, and also give you some insights into standardization, regulation and ongoing H2020 projects. So if you look on all these activities, what has been already achieved, I would say that this is a real option for the next generation. Thank you very much.
I'll have to share the mic again. Thank you, Professor Kürner. Thank you very much for this enlightening talk. I'm sure we should have a few questions here. Or is everybody already? No? Okay, we have some.
Okay. My question is, you presented a lot of very interesting results related to indoor emulation.
Yeah.
Did you try experimentations in outdoor?
Not yet in the
And
moment.
what do you expect that it should happen in outdoor? Do you have any feeling, any expectation?
I would expect that there is, or let's start it from that one. If you start from the indoor, we have also done some comparison between 60 gigahertz and 300 gigahertz, and it was explainable what has happened. I would expect the same thing in outdoor environment. The only thing where we have to be maybe careful and do some initial measurements, although there is one group in the US that has done this already, is with respect to this atmospheric attenuation, because this is something new, which is different, which is not somehow scalable from the lower frequency bands. But I would not expect a big surprise on what I have seen so far.
Okay, thank you.
Thanks. You have another question?
So thank you very much for the presentation. I think this technology is highly competing with free space light communications.
Yeah.
What do you think about that?
Yeah, that is true. That is actually a competing technology. However, in the free space optical communication, there is, if you look for the indoor environment, so the device discovery is probably even a bit more challenging. You might end up with some issues with eye safety. And for the outdoor environment there, I would see for the terahertz you have even some advantages, and there is in the literature some investigations that under conditions with fog and rain, the terahertz has clear advantages over the free space optics.
I guess we are a little bit already into the break, so I will thank again.
Yeah. Thank you.
Just one short announcement still. I know we are keeping you a little bit into the break, but actually during the coffee breaks we are also having exhibition pitch corner. So actually some of the exhibitors will now briefly present what kind of demonstrations they're showing to you. So that's actually at the far end of the exhibition area. You're very much welcome to listen to what they have to say. Yeah, thank you very much for attending this welcome session. Thank you very much.